Okay, before we get going on the balancing lesson, here are the answers to the word equations worksheet. So if you haven't checked those yet, you can check them. I'm just going to kind of buzz through them, but you can always pause if you need to. So I can go down to this one, and then go ahead and pause if you need to look at those better. This is the next sheet. And I think there's some hiding. No, not really. Okay, so you can let me know if you have any questions on those in class. All right, so balancing equations. You have your notes in front of you, and the stuff we're going to go over is all on these notes, but really the idea that we have going on here is that we're going to have chemical reactions, like this one shown here on the board, of sodium and chlorine making sodium chloride. And there are laws in chemistry, like the law of conservation of matter, that say that we can't create or destroy matter. We can only, transform it into something else. And because of that, we end up with this concept of needing to balance an equation. And we will learn really two methods to doing this, but the first method is really just sometimes it works fast and sometimes it doesn't. So a lot of you are going to want to focus on the second method that I'm going to be teaching today. But let's go ahead and start with the first method, which is called trial and error, which is why I said it's kind of hit and miss as to whether or not it's going to be successful fast for you. If you have a really simple set of reactants and products like we have here, then it probably is a good bet that you'll be able to do it relatively quickly. So here's what you do. Make a list of all the elements that you have. In this case, we have sodiums and we have chlorines. You're going to count how many you have on the reactant side versus how many you have on the product side. So if we look at sodium on the reactant side, we have 1 sodium. If we look at chlorine on the reactant side, we have 2 of them. Remember, that little 2 is saying that there's 2 chlorines bonded together. On the product side, I have just 1 sodium and just 1 chlorine. So here's where the trial and error comes in. We know to have a balanced equation, we need to have the same numbers of both of the elements here on both sides. Well, sodium is good. Sodium looks balanced. If you look, we have 1 and 1, but chlorine is not. So if we don't fix this, then we are defying the law of conservation of matter, which of course we are never allowed to do. So what we're going to do is we are going to use coefficients to help balance our equation. Now what a coefficient is it's a number that goes in front of your element or your compound, whatever molecule you have, but it's only changing how many you have of it. Remember, we don't have the power to change actual molecules. We can only affect how many, or alter how many we have of them. So what we're going to do, if you can see here, our issue is that we have 2 chlorines here and only 1 chlorine here. So I'm going to put a 2 in front of the NaCl. Now, I only want the chlorine to go up to 2, but I have to put the coefficient in front of the entire molecule or compound that I have. I can't just change one part of it, because if I change one part, I'm actually going to change what the substance is. So I can't change subscripts, but I can change how many I have. So the good news is, by saying 2 NaCl's, I'm literally saying that there are 2 NaCl's. And so if you look, we now have 2 chlorines. So this number gets altered to a 2. And everything looks great until we realize that when we did that, we now also have 2 sodiums. Okay, that's bad because that one was already balanced and now it's not balanced. So now we go back, we fix the chlorine looks good. Now we need to go to the sodium. So to balance sodium, we know that this 1 that we have right here needs to become a 2. So on the reactant side, we find sodium, we put a 2 in front of it. That will change that coefficient to a 2. And now our reaction is balanced. If you look, we have 2 sodiums here, 2 chlorines, making 2 sodium chlorides, which means 2 sodiums and 2 chlorines. So it's all balanced and good to go. Again, we had to fiddle around with it a little bit to make it work, to get it to work. Go ahead and try another one. So we have CH4 plus O2 yields CO2 and H2O. So again, make a list of the elements that you have. Carbon, hydrogen, oxygen. You're going to count them up on the reactant side and then count them up on the product side. So on the reactant side, I have 1 carbon right here. I have 4 hydrogens, so I'll put a 4 there, and I have 2 oxygens, so I'll put a 2 there. For product side, I have 1 carbon. So look, carbons are balanced. Looks good so far. I have 2 oxygens here plus another one here, so that's a total of 3 for the hydrogen. And then, I'm sorry, that's not right. Those were oxygens I just counted. So 3 for the oxygen. And then hydrogen-wise, I have 2 hydrogens. So I go ahead and put that there. Now, notice our carbons are good, but our hydrogens and oxygens aren't. So we're going to have to do some work here to get this fixed. I'm going to go ahead and start with the hydrogen one. So I know that if I can double how much hydrogen I have on the product side, then I'll be good, if I can get that up to 4. So I'm going to put a 2 in front of H2O2. That changes my hydrogen count to 4, because again, if you look right here, 2 H2O2 is the same thing as saying we have an H2O and another H2O. So I have a total of 4 hydrogens there. But by changing that, remember that also altered my oxygen. So I have 2 oxygens there plus the 2 that I already had here. So now I am up to, if I can count, 4 oxygens. Okay, so my hydrogens and my carbons are both good, but my oxygens aren't. So now we come back to the oxygen. The issue is you have 4 on this side and 2 on this side. You can only make your numbers bigger. So we'll come on the reactant side. If I put a 2 in front of the O2, that changes this to a 4. Okay, so again, we can check now and make sure our thing is balanced correctly. 1 carbon here, 1 carbon here. I have 4 hydrogens here, and over here I have a total of 4 hydrogens since I have 2 water molecules. I have 4 oxygens. Here I have 2 oxygens, and then here I have 1 in each one, but there's 2 of them, so that's a total of 4. So you can always check your work when you're done with your problems. There's one more trial and error one on your paper. We're going to skip over that because I really want to get to this method. Now this method does take a tiny bit longer, especially depending on the problem, but I'll tell you it'll give you an answer every time, and it won't cause you to keep jumping back and forth. Most of the time when people are using trial and error, they eventually screw up because they're bouncing back and forth between them. So don't let it scare you that this is called the algebraic method. It's just a really simple math procedure that can balance your equations. So here's how it goes. You're going to start by putting a letter everywhere where you are going to have a coefficient. So we'll call them A, B, C, and D. You know, one thing I didn't say before, if you pop back over here, notice I don't have a number written here, and I don't have a number written here. If there's no numbers there, it's assumed to be 1. Okay, kind of like we've been doing with our formulas, but I just wanted to point that out. So we're going to get a number here for all of these, A, B, C, and D, and we're going to let math do the work for us. So what you're going to do is put those letters down, then you're going to make a list of all of the elements that you have. So we have carbons, we have hydrogens, and we have oxygens in this chemical formula. Now what we're going to do is write some really simple algebraic expressions. So the first one I'm going to focus on only carbon. Okay, so we look in the A compound. See why I'm calling this one the A compound? There are 6 carbons in A. So I'm going to write 6A. Again, there were 6 carbons in the A compound, so I write 6 times A because that's the value that represents the carbon in that compound. Now in B, you can see here in B there's no carbon, so I'm not going to put anything. When you cross over the yield sign, you put an equal sign for our equation. Now we look in C, the C compound, we have 1 carbon, so 1C, or just write C. And then there's no carbon in D. So our first equation is 6A equals C. Now we're going to leave that one alone, and we're going to focus only on hydrogen. So if you look in the first compound, we have 12 hydrogens in A, so I'm going to call that 12A. There's none in B. I'm going to go across the yield sign, that's an equal sign now. C, there's none, and then there's 2 in D. So I'm going to get 12A equals 2 times D. Now we're going to focus on oxygen. There are 6 oxygens in A. There are 2 in B. So here's what we do. Notice there's a plus sign in here, so you're going to use a plus sign. So 6A plus 2B, because there's 6 oxygens in A and there's 2 in B, is equal to, there's 2 in C, and then there's 1 in D. Okay, so I have a little longer of an equation there. Now we have these 3 equations. We can use them in any order we want. Sometimes we won't even use them all, and that is totally okay. The next step in your paper, it tells you you're going to make a list of all of your variables. So A, B, C, and D. And we're always going to start by assuming that A equals 1. Now I said assuming, and that is what we're doing. It won't always equal 1, but if it doesn't equal 1, it will work itself out. And I will explain later why that is or where that is. So let's start. If we've assumed A equals 1, so if A equals 1, then 6 times 1 is what C is going to be equal to. And so C will be equal to 6. So now I know another variable. Now if A equals 1, then 12 equals 2 times D. So D also equals 6. Okay? And if we look at the last equation, so 6 times A is 6. We don't know what b is, so I'm going to say plus 2b equals 2 times c, which is 12, plus d, which is 6. So if I sort of simplify this, subtract over the 6, I get 2b equals 12. So b is equal to 6. Just real simple, basic type algebra is what we're doing. Now look what we just ended up with. We ended up with a value for each of our variables, and guess what those values are? They are your coefficients in your balanced equation. So you're going to put a 1 here, a 6 here, a 6 here, and a 6 here. So that's how you do it algebraically. So it takes a little bit more work, but you get an answer every time. And if you do it right, of course, you're going to be getting the right answer every time. And it really makes it a little bit more systematic so that you're not playing a guessing game. Now, you notice in this one, a ended up equaling 1, and we had assumed that a equals 1, but that won't always be the case. You're not always going to end up with an a equals 1. So I want to show you one in which that is not the case. So if you take a look at this one, we have barium acetate reacting with sodium phosphate to make barium phosphate and sodium acetate. So again, same procedure as last time. We're going to put in a variable for each one, okay, like so. Then we're going to take and make a list of all of our elements. This one has lots of elements. We have bariums, we have carbons, we have hydrogens, we have oxygens, we have sodiums, and we have phosphoruses. Notice I am not putting the polyatomic ion down on my list. I'm using elements, individual elements. Please make sure that you're doing that. So if we go through and write our equations, we have 1 barium in A, so that's going to be, why did I write that? Oh, yeah, okay. We're going to have 1 barium in A, that's going to be A. And then if you go across, the next one we see is in C. So I'm going to do equals 3C. So A equals 3C. Now for carbon here, notice this 2 outside that parenthesis. Remember we talked about the fact that means there's 2 acetates. So if there's 2 acetates, each one having 2 carbons, that means there's a total of 4 carbons in A. Now there's none in B. Put my equal sign down. There's none in C, and then there's 2 carbons in D. So we'll have 4A equals 2D. For hydrogen, again, 3 in each one, but there's 2 of them. So it's going to be 6A, none in B, none in C, and 3 in D. Okay, for oxygen, there are 4 in A, there are 4 in B, there are 8 in C, and there are 2 in D. And then sodium, if you go to the B compound, there's none in A, so we're going to have 3B equals D, 1 in D over there. And then phosphorus, you have 1 in B, and then here you have 2 phosphates, each one has 1, so that's going to be 2 in C. Now remember I said before, you don't have to use all your equations, so we're definitely going to try to avoid using this one just because it has so many variables in it. Let's make a list of our elements, A, B, C, I didn't mean elements, your coefficient variables, and remember we're assuming A is 1. So if A is 1, we plug it into this first equation, we get 1 equals 3C. Please be very careful. People make this mistake all the time. You're solving for C, so you have to divide over. So C is equal to 1/3, not 3. Okay, 1/3. Now that might feel weird, seeing a fraction, and our coefficients are never to be fractions. They're going to be whole numbers, and so we're going to have to deal with that in a second. But it's okay if at this point it's listed as a fraction. Okay, we'll deal with that and show what to do with it. Now go to the second equation. So if A equals 1, so 4 equals 2D, then that means that D equals 2. So I can plug in my 2 there. This equation doesn't really help me. I already know A and D. Remember, I'm going to try to skip this equation. Let's avoid that one. Let's use this one instead. We know D, and then we're trying to find B. So 3B equals D, which is 2. So B equals 2/3. So we're going to put 2/3 in over here. Now, like I said before, it can't be a fraction. We cannot have coefficients that are fractions. So what we're going to do is come over to our list that we've made now, and we're going to multiply all of these by the same value, whatever the smallest number is that you can multiply and get whole numbers for everything, which, remember from math, it's just going to be the reciprocal of whatever your denominator is on these. So 3 is going to be our multiplier. If I multiply 1 times 3, I get 3. 2/3 times 3, remember the 3's will cancel, you'll end up with 2. 1/3 times 3 will be 1. And 2 times 3 is 6. And those are your coefficients. So you'll have a 3, a 2, you don't have to write the 1's, and a 6. Okay, and you can go double check your work, but you notice here our A didn't end up being 1, but it worked itself out because it showed us a fraction, and that fraction showed us that we had an issue. Now what I want you to do on your notes sheet is to try this next problem that's on your homework. And when you come to class, I'll be looking at it to make sure that you did it. If you run into problems, that's fine, but just do your best.